Hi, welcome you all. In the current lecture, I'll try to discuss about the one-dimensional and two-dimensional structures of the solids. Based on two-dimensional structures, further three-dimensional structures that will be discussed, but the short video I am planning to make. So, one-dimensional structures of the solids. It is given that one-dimensional structure of the solids are formed by the constituents, spheres, particles, it may be atoms, molecules or ions, linearly they get attached with each other. Like the diagram here I am showing, the one constituent is connected to the two more constituents. Okay, and in this way the millions of constituents, lakhs of constituents or infinite number of the constituents get attached and one dimensional structure is get formed. Mostly it is a theoretical concept, that one dimensional concept. Some nanomaterials are get made and they are said to be a one dimensional one. Okay, so infinite number of the constituents, they get linearly attached with each other. Here, even though here I am showing only few constituents, the coordination number in case of the one dimensional structure, the coordination number is how much? It's a 2. Say for example, this sphere if I consider, it is in contact with the two more only neighboring spheres. Suppose I am considering this sphere, so it is in contact with the 1 and 2, these two only spheres. Okay, so except the end constituents, the remaining all are having the coordination number 2, and as we discussed, millions or infinite number of constituents are there. So we should say one dimensional arrangement of the constituents correspond to the coordination number 2. Now based on the one dimensional structure, we have to study the two dimensional structures. So two dimensional structures are of the two types. The first one is square close packed, square close packed two-dimensional structure, arrangement or layer also we may say, because this is going to be used for making the three-dimensional structure. In this case, the constituents, one-dimensional constituents, they are get arranged like I am showing here. This is the one layer of one-dimensional constituent. Another, say for example, I am calling it as a type of layer. Another layer of the one-dimensional constituent, it is placed exactly above to this. So here another one-dimensional layer of the constituents. So the constituents of the second layer are exactly above to the constituents of the first layer. Now next to this, this is the A type of layer over which the third layer we are going to place, and the constituents of the third layer are exactly above to the constituents of the second layer and so on. So here we can make we can show the one more layer, fourth layer. What are the characteristic of this type of the structure? We call it as a AA type of the structure. The characteristic is, first one, it is formed. How it is formed? So it is formed by stacking one dimensional layers. Okay, it is formed by stacking one dimensional layer over another one dimensional layer. Okay, exactly above to the another one dimensional layer. It is also known as the AAAA type of the structure, because the constituents are having vertical as well as horizontal alignment. You are seeing these constituents are having vertical alignment, these are having the horizontal alignment. So there is a perfect vertical as well as horizontal alignment of the constituents. Beside this, the question is why it is called as a square close packed structure. Say for example, if I am considering this particle, so this particle is in contact with the four more particles. So as you are seeing, 1, 2, 3 and 4. So when we join these neighboring constituents, we are getting the square. So that's why we call it as a square close packed structure. Square close packed structure. Okay, and it is applicable for all the constituents. Each constituent is in contact with the 4 more constituents. And last one, what about the coordination number? So as we saw, the each constituent is in contact with the 4 more constituent. The coordination number is 4. Okay, if you are thinking about these borderline constituents, so don't think about them, because there are the millions of or infinite number of the constituents. Here also many spheres, here also many spheres in all direction. Okay, and they are in a 2D manner. Okay, so the coordination number is 4. Now another type of the two-dimensional structure, let me explain. That is nothing but dim. Okay, here another type of the two-dimensional structure, that is nothing but dim. Hexagonal close packed, hexagonal close packed, that is HCP structure or layer or arrangement. All these words are applicable. How it is formed? So first of all, we should have a 1D layer, one dimensional layer. Now constituents of the second layer, they get placed in the depressions of the first layer. How? Let's see. So another one dimensional layer, its constituents are get placed in the depressions of the first layer, as I am showing here in this figure. This is the B type of layer we may call, because arrangement of constituents is different. Now third type is of A type, means what? The constituents of the first layer and the third layer, they are in the alignment, and constituents of the second layer and fourth layer, they are in the alignment. So here this is the AB type of the structure. Now what are its characteristics? The first characteristic, how it is formed. So by stacking okay, 1D layer, or we say second layer spheres, by stacking second layer spheres in depressions of first layer, depressions of first layer, we are getting this hexagonal close packed structure. Now second one, as A and B, these are the arrangement of constituents is different, so it is also called as the AB type of the two-dimensional structure. Now next one, the constituents are neither, they are in horizontal alignment, but vertical alignment is not there. So we can say horizontal or one type of the alignment is there, but another, as shown in the figure, vertical alignment is not there. Now main question, why it is called as the hexagonal close packed structure? The answer is, if we consider any constituent, say for example this sphere I am considering, so this is surrounded by the 6 more nearest neighboring constituents as shown in the figure. Are you getting? So here when we join these nearest neighboring constituents, we are getting here the hexagon. So that's why it is called as the hexagonal close packed two-dimensional structure. Here it is written. And last one, what about its coordination number? So the coordination number is 6. Each constituent is in contact with the 6 more constituents. Now based on whatever the structures we have discussed, especially two-dimensional structures, so based on these two-dimensional structures, further we have to learn about the cubic close packed structure CCP, three-dimensional CCP, three-dimensional hexagonal close packed structure, as well as simple cubic structure. So these three dimensional structures we have to study. Okay, thank you for watching.